Welcome to our second installment in the geometry unit. In section 8.2, we're going to throw in a few more polygons to classify, and we're going to make sure you know how to draw an angle and how to measure an angle using a protractor. So bear with me. Using the protractor on this on the smartboard is not as easy as it looks. So you've got a little chart here. Maybe some of these you know, maybe some you're not quite aware of. But all of these are, the way they're drawn, you can tell that all the sides are the same length within each figure, and the angles within are also actually congruent, meaning the exact same size. A polygon, does not have to be regular, as we've already seen with quadrilaterals. We had a lot of quadrilaterals where all the sides and angles were not congruent, but they were still polygons. So the quadrilateral that is, quote, regular, as far as geometry terms go, is the square. Now, why, oops, I need a little U in there. Why would the rhombus not be, sorry, there's a U in there. Why would the rhombus not be regular? Think about that for a minute. Well, it has the four congruent sides, but it does not have congruent angles. If it had congruent angles, it would end up being a square. I'm going to erase that. I can do better. All right. S Q U K R E. A square. All right, well, let's try our hand at a couple that are non-regular. All you have to be a pentagon is have 5 sides, or a decagon is 10 sides, etc. So I've given a couple of non-regular here. Write down what you think these are, and feel free to use the chart above if you don't yet know all of those terms. Undecagon is probably one that people are less familiar with. All right, so the first one has 1, 2, 3, 4, 5 sides, so that makes it a pentagon. The second one, if you have to look at it, looks like a piece of paper that got the little corners clipped off, but now we have 3 sides, big sides, and then a little one here, the top, and a little one here. So that's 6 sides. So that is a hexagon. A lot of geometric figures show up in nature, and the hexagon always makes me think of a beehive. The honeycomb that bees create are hexagons. Now, a couple of other terms that you may or may not know, and that is convex or concave. Those are some pretty fancy geometry terms, and they are used to indicate, sorry, I'm messing with my pens here. Most of our polygons that we've been talking about already, well, actually all of them have been convex. Notice how there's no sort of dents in it. Everything is pointing out. There's no points going in. But when it starts to kind of cave in somewhere, or it looks like someone punched it, then you have concave. But it's still a closed figure made up of straight sides, so it's still a polygon, it's just concave. So if I counted the sides on this one, 1, 2, 3, 4, this is a concave quadrilateral. This one over here appears to be a trapezoid, but we don't have the markings, but it's also a convex quadrilateral. All right, well, let's do some measuring. So all you need is your protractor, I have a protractor and a ruler, but that's just because I can't use my protractor as a ruler like you can. So on part 2, you may already know how to measure with a protractor. It's actually a very fine motor skill. You have to really be careful to be exact. And the SmartBoard has a couple of extra little things built in that make it a little easier to do. But if you use the protractors we have in class, they're really good. I also suggest maybe you have some, like a note card or something. Sometimes you need to extend a side, and it's good to just like lay the note card down over the protractor. So if I want to measure this angle, first I'm looking at it and I'm thinking, okay, it's obtuse because it is greater than 90 degrees. So if I take my protractor, I want to put the bottom part right at the vertex of the angle. Now mine's pretty straight right now, but if you're off, see, like now I'm not on it because this bottom line is off. You want it to be overlapping the bottom of your angle. Now, I'm right-handed, so you can turn your paper any way you'd like to, but I kind of like the right side of the, oh, now I've got to concentrate here. I like the right side of the angle to be always positioned like this, even if I have to turn my paper, which I don't need to in this case. So if I'm measuring this angle, you see how over here, get my pen to be here. See how it doesn't actually extend far enough? So this is when I suggest you lay your note card down and line it up with this ray really well so that it extends up here. And I measured it by hand at 136. This one is looking to be kind of maybe around 134, but again, it's a little harder. So I can kind of go around on this and see. I don't know. Maybe about 136. It's a little hard to judge, but you'll use your note card and you'll just make a little mark where you think it is. Kind of put one out there, and then you can move that out of the way, and you wouldn't draw that whole thing. You don't need to. And then you can take your straight edge, which is also your protractor. Whoops. Bear with me. Trust me, this is... It looks like it would be easy, but it isn't easy to make this thing turn. And I've even practiced with it. Doesn't look like it. A little sweet spot that lets you turn it. Alright, well, I'm not going to mess with that anymore. Oh, I'm sorry. I was thinking we were drawing an angle. I don't really need a little mark. I just need to measure it. So I'll get rid of... I would just write right here. This is 100. I measured it on paper as approximately 136 degrees. The degree symbol is actually open. Mine looks closed, but that's because it's just hard to write with this marker. Let's see if I can do a better job measuring this next one. But we knew from the beginning it was going to be greater than 90 degrees. Well, let's try this one. Now, you may find that you want to turn your paper around, like I would if I could, which I can't in this particular case, but I'm going to see if I can manipulate my going to kind of turn it upside down. Now, if I was you and I was working on paper, I wouldn't be turning this upside down. But I kind of have to right now. Okay, let's see if I can get this to turn. So see how right there it's off, and now I've got it lined up. So this is along 0. Now from the very beginning, you have to decide, is it less than 90 or greater than 90? And I can see that it is actually less than 90. That tells you which row of these numbers to actually read. So in this case, I would not be looking at the ones that are over 90. I would be looking at this upper little curve where they're smaller. So again, just lay your note card down right here so it'll extend beyond the end, and it looks like it's pretty dead on at 65. It extends right here. So on your protractor there's kind of a lot of little marks. Look at the one that's broken up into tens. So 10 marks between 60 and 70, and so I would call this 65. So let's get this out of the way. And you can actually just write out to the side 65 degrees. Sort of, that's not really how big your degree mark needs to be, but that's how big I have to make it here to not make it close up on me. So go ahead and try your hand at this next one, and then we'll come back and see how you did. So just pause the video and measure the green angle. Alright. So, whoops. So from the very beginning, I know that this green angle is acute. It is less than 90 degrees. Kind of moving my angle a little bit here. And so let's get it lined up. So fortunately, this one's drawn really big. Now, a common mistake on this problem would be for a student to say 170 degrees. But that doesn't make any sense because this is clearly a small angle, much less than 90 degrees. So you're reading the inner curve right here. And when I measured it on paper, I measured it at 11 degrees. Moving forward. Now, you're actually pretty much doing the same thing, but you're actually just drawing. You're drawing an angle. So you have to start by just drawing a line. Now, I usually make mine horizontal, but you may choose to do that any way you'd like. Fortunately, on the smartboard, you can just get a straight line right off the bat. But I would use the edge of my protractor or a ruler to draw a straight line. Then I get my protractor. Now, I like to put like a little point right here. The smartboard won't allow me to do that, but just kind of put a small little, kind of like a little bubble point there. And I get the center right. Oh, it looks like I've got it lined up pretty well right there. And I'm looking for 55 degrees. If I can make this work right on here, oh, I've actually got it there. It'll let me drag it around, and you see the numbers changing in the middle. It actually tells me when I've got it to 55, 54, 55, and then once you click it, it kind of stops, but right here it was telling me I had it right at the right place. So this is where I would just make a little mark out here right up against the edge of the protractor. Then you can move your protractor out of the way and get your ruler. So if I can get this little thing to work for me, I swear it'll let you kind of flip it, but it's not giving me, it's not allowing me to do it. Anyway, you get the deal. You line up your ruler right here and you draw a straight line. Let's see if I can, yeah, I can do that right there. And when you draw an angle, you actually in these cases, we put little arrows on the ends because these little parts of the angle are actually called the rays, and this little point where the rays shoot out from is called the vertex. So this time I am going to label the angle that we just drew. So 55 degrees. All right, so why don't you try the next one? And then we'll come back to the video and see how you did. If you still think you're unsure, well, just stick with me and we'll keep going. So step number 1 is you got to draw some line. Big, short, doesn't matter. Then you got to get your protractor down there. And back. So this time 140. You know what? I need to shift my line over a little bit. So 140. So get this right on the end. Looks like I'm lined up pretty well. Oh, well, that's not what you want to do. So 140. I want to be looking at the big part because I'm coming way over here. So here's 140, right at the same place as 40. So again, you can make a little mark, move your protractor out of the way, and then draw a line through your mark. And I'll put some little arrows on it. And this is a 140 degree angle. So of course, once you draw it, you can just measure it to sort of work backwards. And that is the conclusion. Now, one page that I left out was page 2. Fill in what you think that is, and then you can always just check my key to see if you got it correct. Well, have fun with your protractors, and if you don't have one at home, just plan to do that work here at school.